Hey guys, this is Manin, and in today's video, I am going to explain you the Archimed principle with a hands-on activity. So without any further ado, let's get started. So before we start the hands-on experiment, I would like to tell you the definition of the Archimedes principle. So what is Archimedes principle? When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced. So to understand this, we'll try to break it into two parts, as you can see here. So what does this mean? When a body is partially or fully immersed in it. So this is partial immersion and this is fully immersed. There is an upward force. So what is this upward force? Let me show you. See, I'll try to push the cap down. Even if I fully immerse it, it will come up again. Back to the surface of the water. So this is part 1. Part 2. It is equal to the amount of water displaced. Just to give a clear understanding. If we put the scissors, you see the water level will rise up. That means the displacement. See. You might be able to notice that there is a slight change in the water level. So now, as you might have understood the definition of the Archimedes principle, let's now try it with the hands-on activity. So let's start. Basically, now I'll take this simple. Archimedes principle depends on the density of a body. So the density, what is density? Density is equal to the mass upon the volume. So now let's try it. See, this is an eraser. The density of an eraser is quite higher than the density of water. So what do you think? Will it float or sink? Let's try. It will sink because the density of water was less compared to the density of the rubber. So when a density of an object is higher than the density of the fluid, it will sink. But if the density of an object is lower than the density of the fluid, it will float like this. Even if I push it downwards, it will rise up. Now you might be thinking that plastic is heavier than water. Plastic is heavier than water. So now let me explain you why isn't it sinking. So for that, let me show you this experiment. In here I have two foils. This is foil 1 and this is foil 2. So what we'll do is that we crumple one of the foils and then dip it into the water. As you might be able to see, this is the crumpled foil. What do you think? Will it sink or float? It floats. Even though when I push it down, it won't go down. See, it will rise up again. Now let me show you something interesting. When I take this and I push it down, it will stay down. Now you might be thinking both of them are foils. Both of them have the same density. But actually they do not have the same density. In here, when I was crumpling this foil, some air spaces have been trapped in there. So those air spaces combined with the foil, their total density overall became lesser than the density of water. But this foil, it was directly put into the water. So there was no air spaces contained. So that is why this foil sank, because this foil is made of aluminium, and aluminium, it has a higher density than water. Even though I crumple this, it will still not float. Now you might be thinking this is floating and this is not floating. The same reason. It does not has any air spaces, but this has some air spaces. So therefore, this has a higher density than this piece. So I hope you would have understood. Thank you.